Now we're moving in the direction of symbols. Okay, we have a pretty good grasp of how power function graphs behave and how exponential graphs behave. So we're going to move to the symbol. We've already said that an exponential function, your most basic exponential function, has a graph or has a definition that f of x is b to the x for some number b that's greater than 0. Okay, well, right there is a basic exponential function. And what I want to do is I ask you to simplify f of x plus delta x sub d divided by f of x. Okay, just write out that expression and simplify it. Okay, well, before we get to that, people had a little bit of lack of familiarity with function notation. And unfortunately, this also included people who've completed a pre-calculus course. And that's kind of a little mystifying, but without making too many comments on the status of education, I have to say that it's not totally surprising. And then we want to show in a graph what this result means. Well, that's another question. We had to digress over here to explain function notation, as well as the laws of exponents, because it's important. It's essential that you understand the laws of exponents before you can simplify this. Now, everybody that's had at least Algebra 1 should know the laws of exponents. Not everybody in Algebra 1 understands function notation, so we did need, and I anticipated that we'd need to digress and explain a little bit more about function notation. We've already seen it in relation to a graph, but how does it apply here? Okay, so what I say is f of x equals b to the x. Now, I write down the expression f of 3. And let's ignore what I wrote over here to the right of the equal sign for the moment. We'll see how that comes about. So what's the difference between f of x and f of 3? Just in what I've written down. What's the difference? Well, everything's the same, except that instead of x, I have 3. So I've replaced x by 3. Well, if I replace x by 3, and if I'm going to be consistent, I better replace every x in this expression by 3. And if I do, I'm going to end up with a 3 up here as the exponent of b. Okay, so replacing x by 3, I have to replace all values of x by 3, or all instances of x by the number 3. Now, there's only one instance of x here, that's here, so I get f of 3 equals b cubed. Now, again, of course, this is aimed at people who were in the class, and I should probably do a separate video where I do this step by step. But what do we mean by f of a plus b? Okay, don't look any further. Don't look ahead. Don't look ahead at anything else I've written. What does f of a plus b mean? Okay, you should pause and write out what you think it means. Well, I've written it out, but don't pay attention to that just yet. It's clear that now this expression is just like this, except that x has been replaced by a plus b, so we have to replace x by a plus b, so we get b to the a plus b. Now, one distraction that people were having is trying to figure out, well, what are we going to do with a plus b? Okay, how are we going to calculate with that? That's irrelevant. Okay, it's irrelevant to the fundamental fact that if you got a plus b here, that's what's replaced x, and it has to replace all the other x's. Now, there's plenty else to worry about after you write this down, but there's nothing else to worry about before you write this down. So you don't confuse yourself with what you're going to do later or with what any of this means. You just write it down. Okay? So now, what about f of 4q minus 3p over 7z? Pause, write it down if you haven't already. Okay, well, now I've got it. So why did I write this? Well, I made my exponent 4q minus 3p over 7z because that expression 4q minus 3p over 7z is what replaced x here, and x is the exponent here. So doing the same thing over and over, okay? What about f of aardvark? Well, by this point, people stopped confusing themselves and started writing it out correctly. So, now I want you to do f of x plus delta xd over f of x. You should be able to write that down, but I broke it into a couple of steps for everybody. So I asked people to write f of x plus delta xd. And I think people did that right, b to the x plus delta xd. And then finally, f of x plus delta xd over f of x. Well, f of x plus delta xd is just this, which we wrote down here already, and f of x is just b to the x from the definition. Now I asked people to simplify this, and at this point everything went south. Nobody seemed to know exactly what to do. And this is where I really do have a little problem with our educational system, which doesn't teach people this very well. You've got laws of exponents, and they make sense if you make sense of them. In our typical educational system, you memorize them long enough to use them on the test, forget them, and never really understand them or why they are what they are. If you understand them, you're never going to forget them. Or if you do forget them, you kind of remember what they are and you can test them. So that's what I've done up here. First place, a to the b plus c, well, the law is it's equal to a to the b multiplied by a to the c. Now, if you're not sure about that, you can write down 2 to the 3 plus 4. There's an expression, let a equal 2, b equal 3, c equal 4. And clearly that's equal to 2 to the 7th. Now, what's 2 to the 7th mean? Well, people were pretty quick to respond. Well, it means 2 multiplied by itself 7 times, so we write out 7 2's here. Okay? And then we simply note that, well, what does 3 and 4 have to do with this? Well, you got 3 2's and then you got 4 2's, which means you have 2 to the 3rd multiplied by 2 to the 4th. So we see that 2 to the 3 plus 4 equals 2 to the 3rd times 2 to the 4th, leading us to believe that a to the b plus c should equal a to the b multiplied by a to the c. If you have a simple law, and the law looks like this with numbers 2, 3, and 4, then this is the only way the law can really look. Now, that doesn't prove the law, but the reason for the law is very similar to the reason for all this. Okay, it can be reasoned out by this. Now, the fact that the law applies when b and c are fractional or irrational exponents, well, you kind of make a jump there. You can actually prove it for rational exponents once you get a couple other laws. For irrational, you got to kind of take it on faith or accept something very much like a field extension to the irrational numbers, okay? And you don't need to know at all what I just said. Okay. So now we can do some simplification. Now you should try to simplify this using this law. Okay? What do you get using this law? Okay, well, b to the x plus delta xd is b to the x times b to the delta xd. And of course we got b to the x in the denominator. Does that suggest anything to you? Well, yeah. Divide this b to the x into this b to the x, it's 1, which is then multiplied by b to the delta xd, giving you just b to the delta x sub d. Okay, that's the simplification of this. Now there's more to this, and I'll get to that in the next video.